Welcome to the Unit 5, Section 1 video on types of solutions. A system of linear equations is a set of two or more linear equations containing two or more variables. A solution of a system of linear equations with two variables is an ordered pair that satisfies each equation in the system. So, if an ordered pair is a solution, it will make both equations true. So if we want to identify whether the point 4, 1 is a solution to this system of equations, all we have to do is take our x value and our y value and plug them into each equation. So starting with the first, we put 4 in for x and 1 in for y, and then we evaluate the left-hand side by doing 2 times 1, which is 2, and then add 4 and 2, which gives us 6. That's a true statement, so this is a solution to the first equation. But for it to be a solution to the system, you have to also see if it's a solution to your second equation. So we take our second equation, plug in x and y. 4 minus 1 gives us 3, and it checks out here as well. So the ordered pair 4, 1 makes both equations true, so 4, 1 is a solution of the system. So let's do another example. We're going to figure out if negative 1, 2 is a solution to this system. So we're going to plug in our x and our y values. We'll do 2 times negative 1, which gives us negative 2. 5 times 2 gives us 10. Negative 2 plus 10 gives us 8. So 8 equals 8. That one checks out. Now let's plug that point into our second equation in the system. And we get 3 times negative 1, which is negative 3. 2 times 2 is 4, and negative 3 minus 4 gives us negative 7. That is not a true statement. So since it does not satisfy the second equation, it is not a solution to the system. Even though it does satisfy the first one, it's got to satisfy both for it to be a solution to the entire system. When two lines intersect at a point, there's exactly one solution to the system. A system with at least one solution is a consistent system. Consistent systems can be either independent or dependent. An independent system has exactly one solution. It has one independent solution. The graph of an independent system consists of two intersecting lines. A dependent system has infinitely many solutions. The graph of a dependent system consists of two coincident lines, which means one line is on top of the other, and it appears to be just one line on the graph, but one is sitting right on top of the other. So the two lines are dependent on one another. So it is a dependent system. When the two lines in a system do not intersect, they are parallel lines. There are no ordered pairs that satisfy both equations, so there is no solution. A system that has no solution is an inconsistent system. So let's talk about the classifications of systems of linear equations. If we have one solution, we have different slopes and intersecting lines. A consistent and dependent system has infinite solutions. It's the same slope with the same y-intercept, and is coincident lines. So it looks like one line on the graph, but one line sitting on top of the other. And then inconsistent equations or inconsistent system has no solution. Same slope, but different y-intercepts in an equation. So you have parallel lines. They will never cross. And so we will never have a solution. So in example 3, let's classify the following system and give the number of solutions. Well, what we're going to do is we're going to rewrite both of the equations into slope-intercept form so we can compare the slope and the y-intercepts. So for this first equation, all we got to do is divide everything by 2, and we get y equals 1/2 x plus 1. For the second equation, we first have to add 1/2 x to each side. Then here we've already gotten ourselves into slope-intercept form. So you'll notice that we have the same slope and the same y-intercept. It's essentially the same equation for both. So therefore, the system has the same slope and the same y-intercept, making it consistent and dependent. Remember, if we have solutions, it's consistent, and if the lines are on top of each other, they are dependent on one another. It has infinitely many solutions. In example 4, classify the following system, and we're going to give the number of solutions. Again, we are going to put this in slope-intercept form. So in the first equation, we distribute the 2, and we get 2x minus 2. The second one is already in slope-intercept form, but just to make the point, when x is by itself, our slope is 1. So we have a different slope and a different y-intercept. So we have two independent lines. So we have a solution. It's consistent. The lines are independent of one another, and it has one solution because those two lines will cross at one point. For this system, we are going to solve the first equation for y. So subtract x from each side and divide each side by 2, and you get negative 1/2 x minus 3. For the second one, we're going to distribute the negative 2, and then we're going to add 4 to each side, and then finally divide each side by negative 2, which gives us negative 1/2 x minus 2. So we have the same slope, but different y-intercepts, which means that the system is inconsistent because the lines would be parallel to one another, and it has no solution. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.